Charles-Augustin de Coulomb by Emily Dedoyard. Over the last 7 weeks of class, we have largely focused on electric force. This is a very important concept to understand prior to going further in the course and learning how electricity and circuits work. We have used Coulomb's law to solve many different physics problems, and now I would like to discover more about Coulomb and how he made the discoveries in electric force that we continue to use to this day. Coulomb was born on June 14, 1736, to a wealthy family who lived in France. He went to the College of Four Nations and studied mathematics prior to enrolling into military school at the age of 23. During his time in the military, he graduated from engineering school, and after this accomplishment, he went on to leading the project of building Fort Bourbon, which is depicted in the bottom right-hand corner of the slide. After having health issues, he returned to Paris and studied force of charge at the Royal Academy. This is the place where he began conducting the first experiments dealing with quantitative analysis of electricity. He worked at the Royal Academy from 1785 to 1789. Coulomb had to overcome several different challenges over the course of his career. First, after Coulomb condemned a plan to build a canal that he felt was not worth the money or time, the bureaucracy grew angry and penalized him. After attempting to resign, he was told to look over the plans again. He came to the same conclusion, and an outside group was hired to look at the plan and prove Coulomb wrong, but they actually agreed with Coulomb's evaluation. This is one conflict that led to him stepping away from engineering and pursuing physics. When he decided to do so is when he made huge discoveries like Coulomb's law. However, he was later expelled from the government work he was doing after the beginning of the French Revolution. This led to his retirement in 1791, but he continued his research at his estate for the remainder of his life. During his time working in physics, Coulomb grew interested in the relationship of charged particles in terms of electric force. In order to test some of his hypotheses, he suspended a needle on a fine fiber of silver, copper, or silk. A small charged ball was held by the needle and fiber on one end, and on the other end was a counterweight used as a balance. Coulomb noticed that when he brought a similarly charged ball to the small charged ball located on the one end of the needle, he was able to see there was a repulsive force between the objects. Later, he did a more quantitative study on this model of electric force and found that the repulsive force of two small globes with the same nature of electricity is inversely proportional to the square of the distance between the centers of the globes. A representation of his experiment can be seen to the right. Continuing his experiments with electric force, Coulomb noticed that when he put objects that had the opposite sign charged together, his prior experiment failed because the objects would attract and stick together. After working through this and conducting additional experiments, Coulomb came up with the law that everyone in physics knows him for today. Coulomb's law states that the force of attraction or repulsion acting along a straight line between two electric charges is directly proportional to the product of the charges and inversely proportional to the square of the distance. This can be represented by the equation Fe, or force, equals Ke, or Coulomb's constant, times the magnitude of charge 1 times the magnitude of charge 2, all over the distance between the charges squared. He also concluded that for a charged metal object or other conducting object, all the charge resides on the surface, no matter the shape of the object. Coulomb is known in physics for laying the foundation of understanding electricity and electric force. Here is a real-world example using Coulomb's law. Say you're having a lazy day and you forgot to put all your laundry away that you did earlier. When you take it out of the dryer, you realize that two of your shirts are stuck together. The charge on the blue shirt is positive 5 microcoulombs, and the charge on the red shirt is negative 3 microcoulombs. Using Coulomb's law, you can answer the question of the electric force between the shirts at 1 meter and 5 meters apart. After solving the problem using the equation, you can clearly say that the stronger electric force between the shirts occurs when they are closer together.